Hello everyone, in this video we will be solving the problem 106, construct a binary tree from Inorder and Postorder Traversal. The problem statement is, we are given two integer arrays, Inorder and Postorder, where Inorder is the in-order traversal of a binary tree and Postorder is the post-order traversal of the same tree. We need to construct and return the original binary tree. If we look at example number 1, here we are given an in-order and post-order array of integers. Based on the information that is provided to us, we need to build a binary tree which would look something like this, with 3 as a parent node, 9 and 20 as the left and the right node, and so on and so forth. Let's switch to whiteboard and understand how we can construct the binary tree using the information that is given to us. To understand how we can solve this problem, I will be using this example. Instead of numbers, I will be using letters. If I go back to basics, the way post-order traversal works is, we iterate from left to right and then root. And for in-order traversal, it is left, root and right. Based on this logic, we now need to make a pattern out of the data and build the binary tree. Let's start with looking at the post-order. Post-order traversal is always from left to right and then the root. So we can safely say that the root of our tree node is always going to be at the last. If you go back and try to iterate through any of the binary tree, you will notice that the root of a binary tree is always traversed at the end. We can safely say this A is the root of our tree node. So I will put A over here, marking it as the root. Now we need to identify how many nodes are to the left of A and how many are to the right. To do that, we will be using the in-order traversal. Let's locate the node A in our in-order, which is over here. Given the nature of how in-order traversal works, root is always in the center. So we can safely say that anything before the root is going to be on the left side of the node, and anything on the right or that's coming after the root node is being traversed is going to be on the right side of the node. I hope it is making sense to you. If it is not, be patient because we will be going through the next set of examples in this traversal which will make it easier to understand. We are looking at A, so I will just mark these two sides, and on the left hand side I will say I can have D, B and E, and on the right hand side it will be F, C, G. Now let's continue iterating on the left hand side. Now we need to understand how we can find out which is the immediate node or immediate left node of A. To do that, we will switch back to the post-order traversal, go from right hand side to the left hand side, and whichever value comes first from D, B and E will be the immediate left node of A. The reason is the way post-order works. When we are doing a post-order traversal, we are going from the very lowest element in the tree and move upwards. So when we are looking at the traversal, and if we want to find out or we want to build the tree from top to down, we need to start looking in the reverse direction. That is from right to left. So if we look for D, B and E and which one occurs at the last or first from right to left, we can see B is the node. So we will make B as the left node of A. Just like with node A, where we used node A to split up the in-order traversal to find out which nodes were to its left and to its right, we will do the same over here, where B will become the anchor and help us out which nodes are to its left and to its right. So with B in the center, that tells us that D is going to be to its left and E will be on its right. Let's look at the right node of A. So just like we did for left, we will be following the same pattern. So now we have F, C and G. To find out what is the immediate right node of A, We will again go to post traversal, go from right to left, and see out of F, C, and G which comes first. So if we start the traversal, node C is the first element that we encounter, which is part of F, C, and G subset. We will add C as the right node of A. When we make C as an anchor, we are left with F on its left and G on its right. So that tells us that F is going to be the left node of C and G is going to be the right. This traversal or loop will continue until we are left with no nodes, or all the nodes have been added to our binary tree. This is how you can solve or construct a binary tree using post order and in order traversals given to us. Thank you for watching this video. I hope you were able to follow this explanation. Feel free to reach out to me if you have any questions, and I will see you in the next video. Thank you.